Welcome to another class with Mathemasoft, and in this class we'll be looking at how to rationalize using a conjugate surd. Okay, so we started rationalization in the previous video, and when we are talking about a conjugate surd, we want to look at what a conjugate surd is before we can apply it to rationalization. So for example, if I have 2 minus 2 root 3, or let's just say just root 3, 2 root 3. Okay, now this is in surd form, in the sense that there is root 3 there. Let's say this is what I have in my denominator, 2 minus root 3. Again, we can see that yes, the denominator cannot be left like this, just like we explained in the previous video. It cannot be left like this, so we must find a way to change it to what? A rational number. Then what we use as the approach in the previous video cannot work again, because for example, if you say, oh, it is root 3 that is here, so let me just take root 3 and root 3 for the numerator and denominator, so that this can become a rational number. That will not happen. It cannot work. And let us see how that cannot work. 1 times root 3 will give me what? Root 3, and then I'm going to have root 3 into bracket 2 minus what? Root 3. And then I will have root 3 over root 3 times 2 will give me 2 root 3, and then root 3 times root 3 will give me root 9, which will give me 3. So this is what you will have. You can see that you have resorted to another irrational expression. So there is still root 3 in the denominator. So a single rationalization like this cannot remove the roots, of an expression like this, because it's not a single surd. And that is why we must use the approach of a conjugate surd. So what is now a conjugate surd? Let us look at what we can use to rationalize something like 2 minus root 3. Let's say we multiply this by 2 plus root 3. Let's see if it will result to a rational number. So that will be 2 bracket 2 plus root 3 bracket minus root 3 bracket 2 plus root 3. Okay, 2 times 2, 4, plus 2 root 3 minus 2 root 3 minus 3. Because root 3 times root 3 will give me root 9, and that will be 3. Okay, so if you look at this is the same root, this is the same root, so we can combine them, and that will be 2 root 3 minus 2 root 3. It's just like saying 2x minus 2x. Of course, this will be 0. So definitely 2 root 3 minus 2 root 3 will also give me 0. And that makes it easier. That will be 4 plus, this will result to 0 minus 3. And my answer will be what? Equals to what? 1. 4 plus 0, 4 minus 3, that will be what? 1. So we have been able to turn this to what? A rational number. Now, if you observe what we use to multiply this 2 minus root 3 so that it will become a rational number, it's almost the same as 2 minus root 3. The only thing that is different between the two of them is their sign. While this is minus, this one is what? Joined with what? Plus. Because this one with plus is the only one that can turn the one with minus to a rational number. Hence, we call these the conjugates. Okay, let me write it. Hence, we say 2 plus root 3 is the conjugate surd of 2 minus root 3. So you see that? So the conjugate surd is only different from the original surd only with what? Sign. Okay, 2 plus root 3 is the conjugate of 2 minus root 3. The difference between them is just what? The sign. Why this one is minus, this is what? Plus. And it is only the conjugate of a surd like this that can turn that surd to a rational number. So when you have an expression, you use its conjugate to turn it to what? A rational number. And that is why if we must rationalize such an expression, we have to rationalize using the conjugate surd. Okay. Likewise, we can say otherwise that if we also have 2 root 3 and want to rationalize it, the conjugate of 2 plus root 3 will also be what? 2 minus root 3. So the conjugate of a surd is only different from that surd by the sign. If the original surd is in plus, the conjugate will be what? In minus. If the original surd is in minus, the conjugate will be in what? In plus. That's what we mean by conjugate surd. Let's now look at an example. Okay, just an example, and in the next video we can do more so that we can shorten this video. So rationalize 2 over 1 minus 2 root 3. Okay, so if we are to rationalize this, then we know that this is already an expression, a surdic expression, okay, and a rational expression, and we must rationalize using its conjugate. So what will be the conjugate? We say this will be 2, let me clean that, pardon me, 2 over 1 minus 2 root 3. So to rationalize this, we are going to have 2 over 1 minus 2 root 3, and then we do it with numerator and denominator. The conjugate is 1 plus 2 root 3. It will only be different in sign, okay, and this will also be 1 plus 2 root 3. Okay, so we can take them together now. 2 bracket 1 plus 2 root 3, 1 minus 2 root 3, okay, bracket 1 plus 2 root 3. All right, so we can now expand. This will be 2 times 1 will give me 2. 2 times 2 root 3 will give us what? 4 root 3. We may not even need to open this, but let's just open it. All right, and then we are here now. We want to expand denominator. 1 times 1 will give us 1, times 2 root 3, that will be 2 root 3, minus 2 root 3 times 1 will give us minus 2 root 3. Okay, minus 2 root 3 times minus 2 root 3, that will be minus 2 times 2 will be 4. Root 3 times root 3 will give me 3. Okay, because that will be square root of 9, and that will be what? 3. And then I can write this as 2 plus 4 root 3 over this, and this will combine to become 0. That will be what? 1 minus 4 times 3 will give us 12, and this will be minus, or let's first write what we have up there, 4 plus 4 root 3 over minus 11. So if I have minus 11, of course we can turn that one back to the factorized form, which will be 1 plus 2 root 3. Okay, it could have been easier if we have something like a an even number in the denominator so that we can actually cut it, but let's leave it in the simplified form. So that's 2 bracket 1 plus 2 root 3 over minus 11, and then we can write as minus 2 bracket 1 plus 2 root 3 over 11. This will be our simplified answer. Now you can see that our denominator is already written in rational number, and hence we have rationalized the denominator, and we did this using the conjugate surd. So I hope you do understand this. Let's look at more examples in the next video. Bye for now.